experienced this technology before. I'm going to have awkward pauses as I wait for some folks in the chat. If I don't see any messages, we're just going to wait on this slide. So have you heard of the mainframe before? Have you leveraged this technology in any way? Do you have any understanding of it? I'm in the chat. I'm stalling until I see some messages pop in. Just take a sip of coffee as I wait. I'm not seeing any messages come in, so I'm going to assume that maybe no. Maybe we've never heard of this mainframe before. All right. Thank you, Hutaifa. Appreciate the comment. I hope I'm not butchering your name. This is your first time learning about the mainframe. So that's what I see out there. I mean, I go around, part of my job is to reach out to university students and early professionals to just introduce them to the platform. We find that just people don't know about the mainframe. You know, it's a reliable technology. It's been around for a while. It's been evolving. Every 3-ish years, we come out with a new IBM Z mainframe with the latest and greatest technologies interwoven into them that we'll kind of highlight later on. But awesome. I'm excited to kind of share this technology with you. It's one of the things I love to do. But before we kind of talk about the mainframe, I want to just sort of set the context for the landscape of technology and talk about what happens in 1 second on the internet. We all know it. We're on our phones all the time, social media, way too much. I had to set screen limits on my Twitter, or my X rather, because I was on there too much. But to talk through what happens in 1 second on the internet is really going to help us understand the scale of the mainframe. So on the internet, we see over 1,200 posts on Instagram. We see over 10,000 tweets on X or Twitter. We see over 98,000 videos uploaded to YouTube. We see over 106,000 searches on Google. And a lot of these are me searching what happens in 1 second on the internet. And while that all seems like a ton of data moving through the internet, moving through the web space every second, it pales in comparison to the nearly 1.2 million transactions moving through IBM Z machines each and every second. That is just an insane amount of data. I mean, every second there's nearly 1.2 million transactions moving through these machines around the planet. And I mean, that's just a number. Transactions are just a word. But what these transactions are they are the data points that are fueling the world's largest businesses. We see 7 of the top 10 global retailers powered by IBM Z mainframes. 90% of the largest banks in the world, 90% of the world's largest airlines, and 80% of the world's largest insurers are all powered by IBM Z mainframes. So what that means is those transactions, that 1.2 million transactions, those are bank transactions. That's every time you take cash out of an ATM, every time you swipe your credit card, every time you swipe your debit card, every time you book a flight, every time you have to file an insurance claim, every time you buy something at the store. You know, that like tap to pay technology, that's connected to a mainframe somewhere, ensuring that everything goes through smoothly. And this is just a few types of the industries. Governments are some of the biggest mainframe customers. As we'll kind of highlight later on, the mainframe has a huge focus on security. There's kind of 3 pillars that I want you to think of when you think of the mainframe. And one of those pillars is security. These are the most secure systems on the planet. We'll kind of highlight later on some of the latest and greatest technology that makes these systems so secure. But in essence, and what we'll kind of come back to a lot here, is they are so secure because they have to be so secure. I mean, this is your financial data. These are your credit card numbers. With the government, it's like your social security numbers, your tax information. It's your most sensitive data that's moving through these machines. So security has to be a top level. It has to be a priority. So it is. So that's one of the pillars. We'll get to the other two as we move along here. But now we know like what these transactions are. We know the kinds of businesses that they're working with, but we still haven't really answered that question. What is a mainframe? And this isn't just kind of like a buzzy word on my screen here. They truly are IT's best kept secret. I mean, so many of you who type out there hadn't heard of a mainframe. This is your first time experiencing this technology, but you're using it every single day. And what does that mean as a kind of an early professional or someone looking to start in technology? I mean, you hear about AI, you hear about Google, you hear about Amazon Web Services, you hear about machine learning. I mean, these are all technologies that we'll talk about how they incorporate on the mainframe. We're going to dive into AI on the mainframe actually in a few slides. But those are the areas that you hear about. Those are the areas that everyone is excited about. And when you are one individual amongst thousands, hundreds of thousands who are vying for these cloud computing jobs or these application developer roles out there, it's easy to get lost in the crowd. You could be the best person for a job, but because there are so many people applying, it's really difficult to make yourself stand out. But if you're targeting a technology that's a little bit more under the radar, a little bit more secret, but still just as crucial, if not more important, it vastly opens the doors for you. It shows that like you're the best person for the job, but now you're one of 1,000 applying, one of 100 applying, and that just increases your odds of getting noticed. But now that we know, I mean, so this is what the mainframe looks like. They're big boxes. I think they're very well designed. They're about six. I'm showing my American here. They're about 6 foot 5 inches tall, which I believe is just a bit over 2 meters tall. And they are incredibly powerful machines. So here's kind of what that transaction looks like. My slide's getting a little overlapped here. But here's what those transactions looks like, right? So there's 1.2 million of these happening a second. And in short, let's say you, the user at the far end of the screen there, are online, you want to buy some new shoes. So you're on your device there and you're on whatever website you're on and you press buy on some new shoes. That transaction, that data point is going through your cloud provider network. So your public cloud, this could be your Amazon Web Services, Google Cloud, Microsoft Azure, IBM Cloud. It's moving through those kind of public cloud provider networks through the various cloud applications that service that you're buying the shoes is leveraging. And then ultimately through some enterprise integration services that connect that public cloud network to that private cloud enterprise network, which more often than not is an IBM Z machine. The IBM Z box is kind of looking for two things. It's looking to make sure that A, you are who you say you are, and B, you have the funds required to make this purchase. Once you get the double thumbs up, it verifies that there's no fraudulent activity going on. That transaction will bounce back out to you and you will see transaction approved. Your shoes are on your way. And this whole thing, this whole process, it happens in a matter of milliseconds. Again, because it has to. I mean, we're so used to everything happening as fast as possible. Everything is happening quicker and quicker on the internet. When you press buy and you see that spinning wheel for even 5 seconds, you start to get a little nervous. You're like, I wonder if this transaction's going through. You don't want to refresh the page because then maybe the transaction will get canceled or maybe it'll go through 2 times. So these transactions happen, they have to happen quickly so that you, the consumer, don't get nervous. You know that your transaction is going through and you know that your product that you're paying your money for is on the way. So that, in a nutshell, is what a transaction looks like. Next up, I'm going to dive into some of the different technology areas that you can work on in this field. Before we do so, does anyone have any general questions about the mainframe? Maybe about like how they work, about the box themselves, anything at all. I'm going to pause here to take a sip of coffee to see if you guys have any questions. Who uses mainframes? And what operating system? Great question. So who uses mainframes? So these are some of the jumped ahead. So these are some of the industries that use the mainframe. I'm not like allowed to name our clients specifically, but think of the largest banks in the world. Think like Bank of Blank. So like every kind of country has their national bank or smaller banks within. Those banks are all using the mainframe. If your company gets to a certain size and you have a high transactional workload, it makes the most sense. It's most cost effective to use a mainframe. There are also a lot of security regulations globally, especially with banks and governments and insurance companies, anything that handles financial information. There are government regulations that mandate that sensitive information has to be kept in a very secure environment, and mainframes meet that security requirement unilaterally across the globe. So really any company that's handling that private information or any company that grows to a certain size will use the mainframe. What are the operating system it uses? So there are kind of two primary operating systems that are leveraged on the IBM platform. One is IBM Z OS, the Z operating system. It's an operating system that's developed and run by IBM. So we're kind of consistently making improvements to the operating system. You can use a myriad of programming languages within the ZOS. I'm going to highlight that in a couple of slides here. And it's kind of like that core operating system. So there are a lot of applications that run on ZOS. There's a lot of different ways that our clients are leveraging it. The other primary operating system that a lot of our clients are using is Linux. So if you have any familiarity with Linux, you kind of know that Linux is fun because you can do anything really that you set your mind to in a Linux environment. So a lot of our clients are using Linux on Z to really expand the use cases of this big expensive box that they have in their data centers. So those are kind of the two primary operating systems there. Great questions. Thank you both. So moving ahead, and again, if there are questions along the way, just kind of drop them in the chat and I'll answer them. So these are kind of four of the different areas that you might be interested in working a career in, that you can work in a career in the world of enterprise computing. So first and foremost is hybrid cloud. If you've seen an IBM commercial on the TV or on the internet, it's going to be like saying hybrid cloud, hybrid cloud. Hybrid cloud is the future. Hybrid cloud is a lot more simpler than you might think. Yeah, I'll give a history on mainframe in after I finish up talking about hybrid cloud. So hybrid cloud is simple. It's just partnering your public cloud services with your private cloud services. And so more often than not, the private cloud component in a hybrid cloud infrastructure will be an IBM Z mainframe. It's all about security. I mean, that's what I've highlighted earlier. That's one of our pillars is security. But IBM Z mainframes are expensive. So a lot of our clients will leverage public cloud infrastructure as well because everything doesn't need to happen on a mainframe. A lot of what companies are doing can be run on more cost-effective services, but then they'll touch the cloud when they're handling that sensitive data or when they need to run transactions at a high volume. So a quick history on the mainframe. So the first mainframe came out in 1964. So the mainframe just turned 60 years old as a platform this April. And the first mainframe looked wildly different than these big boxes here before. They were all about kind of running punch cards as efficiently as possible. So it was kind of like the predecessor of writing code on a computer is you would fill out all these punch cards, you would click holes in them, and you would feed them through the machine and it would run them. You needed people to do a lot of manual effort, but the mainframes at first, it was called a System 360, was able to run things so much more effectively than ever before. And as the mainframes developed over the past 60 years, they just got more and more advanced, and they actually had some of the kind of biggest leaps forward in terms of compute power. Um, for instance, I think it was the IBM S70, I want to say, that came out in the early 70s. That was the first time that um, code was written that could be transferred to different machines. So prior to that machine, anytime you wanted to write an application, you had to hard code that application into the machine that you were working on. But with that System S70, you could actually write that code on a machine, and you could download that code onto a drive. It looked very different to like a USB or even a CD that we use today. And you could move that drive and you could plug it into a different S70, and it could download that software. Excuse me. So it was the first ever time that hardware and software were separated, which was really cool. And then into I think it's the late 80s, it was the first time that a silicon chip was developed for a computer, was for the mainframe that came out in that time period. Which, I mean, if you've heard of Silicon Valley in the US and California, it really kind of having these silicon chips really exploded our opportunities to make things smaller and smaller in terms of chip design. And then over the years since then, mainframes have just gotten smaller. They've gotten more streamlined. I mean, this is a full 4-frame mainframe. It's, as I said, about 6'5" tall or 2 meters tall. It's probably about 1.5 meters wide. But these mainframes used to be a full room. Your whole room would just be a mainframe. Exactly. It also got cheaper as we've developed over time. They're certainly not cheap. These are expensive machines. But you used to have to pay them off for your whole company's existence, and now you can actually pay them off. So I hope that's a good lesson. There's some amazing advancements on the newest IBM Z16, but you got to wait on those because I've got them focused on a slide to come. And they are some very exciting stuff. So moving on to some of the other areas that you can work on in a mainframe career. I mean, analytics and AI, these are two industries that are powered by data. And as I mentioned, we're going to dive into AI on the mainframe in a few slides here. But AI is all about data. You have to have good data, you have to have a lot of data, and you have to know how to mold that data. And with nearly 1.2 million transactions every single second, I mean, that's across all mainframes around the world. But your mainframe that you have in your shop is going to be running a high transactional workload. And that is a ton of data for you to play with, for you to mold, for you to model, for you to better understand your customer. And we're going to dive into some examples into how our customers are leveraging this data that they're obtaining with the newest advancements in AI for some really amazing things. And then Internet of Things, IoT, that's kind of another really hot industry right now. It's pretty much just another way to collect data and collect new kinds of data. So for instance, like anytime you do like tap to pay, or if you swipe your card at a kiosk, that device that you're using is an IoT device. And so that's collecting new data that's linked to your transaction that can help these companies, your banks, these retail companies, better understand you as their customer so that they can better serve you and they can provide better services. This next slide is fun, and it really highlights pillar number 2 of the mainframe. This slide documents the open source software ecosystem on the mainframe. So kind of to go back into the history lesson here, when mainframes first came out, a language came out with it called COBOL. It's an object-oriented business language. It's very, I won't say clunky. People really like COBOL if they know it and they've been using it for years. But it's like an old school coding language. Like is very much like written in English. So you write like add 6 to list 7 or something like that instead of like writing a function that you might write in Python. So it's very much written in English. It's kind of a lot of people aren't learning those skills anymore, but that was the language that worked on the mainframe. If you were working on the mainframe, you had to know COBOL. There's also JCL, which is the job control language, which is how you submit jobs on the platform, which was also like if you use a mainframe, you have to know JCL. But as we've really modernized the platform, we've come to understand that not everyone knows COBOL. And a lot of students out there, a lot of early professionals are learning Python and Java and R and Go, and they're using Node.js. And we needed to adapt and we needed to ensure that these languages worked in ZOS, that they worked in an IBM Z environment. So pillar number 2 is open. These machines have a huge open source software ecosystem. The data, of course, is not open source because this is very sensitive data. But the operating system, I mean, we use Linux as our secondary operating system, and that's as open source as technology gets. So we've really kind of modernized the IBM Z platform so that anything that you've learned in school or in life in terms of programming languages or big data tools or databases or container services, we've allowed it so that you can pull all of that knowledge, all of those learnings into a career in mainframe. I always like to think of mainframe as an and not an or. It's not like, oh, shoot, I have to learn Python or COBOL, or I have to learn R or JavaScript, or I have to use MongoDB or MySQL. It's all an and. So you can learn Python and COBOL, Python and Java. Everything that you learn, you can pull into a career in mainframe because we've opened up the platform so much. So now our pillars to remember are secure. It's got to focus on security, and open because we've got to focus on open source technology. EARTech is asking, does IBM provide IBM Z hosting cloud like Google, AWS, and Microsoft? So we have it in a couple of different ways. So as I'll highlight later on our IBM Z Explore learning platform, where you actually get your own IBM Z sandbox environment on your own machine using this open source tool called Zoe. And that gives you your own IBM Z environment. It doesn't really have any like APIs or services tied in. It's really just a learning environment for you to go through the steps and start to understand how everything works. One of the challenges as you progress into the advanced stages of IBM Z Explore gives you access to an IBM Linux One machine. And as you can see on this slide, it's the IBM Z and Linux One open source software ecosystem. So what the Linux One is it's a mainframe and IBM Z machine that runs Linux as its primary operating system. So our clients who are using Linux Ones can do just so much. It's a newer technology. More clients are adopting it every day, and it has the opportunity to replace their kind of traditional x86 public cloud infrastructure in a way I'll highlight on the next slide, but it's really allowing them to slim down and streamline their businesses. And so through Z Explore, you can learn how you can get access to your own Linux One environment that actually comes with like a machine learning lab. So it's a really good opportunity to like interact in a Linux environment and learn those skills as well as some machine learning. You train like a computer vision model on how to identify numbers, like handwritten numbers, which is really cool. So there are opportunities to experience and interact with IBM Z without actually having a box, but it's not as widespread as like playing around in a Google Cloud or an AWS environment. It's much more like refined around education. So moving on, I want to talk about this is really a form of responsible computing. As we've seen kind of AI explode over the last couple of years, we've also come to understand a little bit better the impact of this artificial intelligence technology. It is highly energy intensive. It takes up a lot of space for these servers, these warehouses of servers that are running like the GPT systems, for instance. It takes a lot of energy to power them. It takes a lot of water to cool them. They're not green machines for the most part, but the IBM Z and Linux One boxes are really, they're responsible forms of computing. This graph here on the slide highlights a partnership between IBM and a Dutch local government agency in which we transition their 47 x86 blade infrastructure. So that's a lot of servers. That's like stacks on stacks on stacks of servers to just two Linux One servers. So just two of those, like earlier I showed four, like a 4 frame. This is a 2 frame, so half that size. And it led to an 80% reduction in energy usage, which is just insane. I mean, that is exceptional for the future of our planet. If more government agencies and banks and companies transitioned their x86 blade infrastructure to Linux One or IBM Z machines, I mean, if everyone took an 80% reduction in their IT operation costs, the ripples outward on our planet and the future of our planet would be tangible. But beyond just kind of our future, which I always like to think of, the cost savings are just next level. I mean, you're saving so much money on physical space because you don't need as large of a space to house these two machines that you needed for 47 x86 blade towers. So you're saving money on the physical space, but you're also saving all that money on energy. You're saving all that money on water bills because you don't have to cool as much space. And it's really just propelled this Dutch government agency's ability to manage their tax dollars. I mean, when it's a government agency, you want them to save as much money as possible. And through these systems, we are able to save them a lot of money. They're also responsible because they maintain a standard of reliability that is unparalleled across the industry. I mean, we see it all the time with like Meta or TikTok or what have you. Like sometimes the servers go down and you open Facebook and nothing load, or no one's on Facebook anymore. You open Instagram, you're trying to watch some reels and nothing is loading. And you look it up like down detector and you see, oh crap, Instagram's down, whatever. You close the app, right? You put your phone down. It's not a big deal. It's a little bit annoying, but the world keeps moving forward. If IBM Z machine goes down, that means you can't withdraw money from your bank account. Your credit card transactions aren't working. Maybe you're about to jump on a flight and they can't properly track your scanning your ticket. And so the flight gets delayed. Like there are real big impacts when IBM Z machines go down. So they don't really go down. This is our third pillar here. So we've got open source, we've got secure, security, and we've got on. These are open, on, and secure. And the on is all about the reliability. Mainframes, we're really excited about this. Earlier this year, we just hit 8 nines of reliability, which means that mainframes are on 99.9999999% of the time, meaning that a mainframe only goes down every year for about 3 seconds, spread out across the year. So most of the times that will be just for a couple of milliseconds every night to just kind of download a software update or something like that. And they're always planned, so they're like, if you swipe your credit card and it doesn't work, it's like, oh, that's weird. You swipe it again, now it works, because that's how quickly these updates happen, because they have to happen quickly. Again, these machines can't go down. It's terrible for the consumers, but it's terrible for these businesses. There's some statistic around mainframes being down for even 1 minute can cost a company millions of dollars. So they stay up because we need them to stay up. Our clients need them to stay up. And you all, as the consumers, need them to stay up. Exactly, Zayed. Security is paramount here. How can you prepare for remote job opportunities? I'm going to highlight that at the end here to really talk about what you should do for learning skills. But moving on here, now's where I want to kind of highlight those two latest and greatest features on the IBM Z16 machine. So this was a box that came out just about 2 years ago. Our clients got their hands on them within the last year. And there are two huge technology advancements that are really leading a lot of innovation on the platform. One is the brand new Telin chip processor. And this is a first of its kind dual chip processor. So you can see there with those two black squares on the right side of that image. Those are actually two separate chips that allow for AI to occur in real time. So we have this cool system that's been worked out called on-chip AI acceleration. And what it essentially does is it works the caching system on the chip so that two transactions are processed simultaneously. So the best way I can explain that is, let's say you are a bank and you're trying to monitor for fraudulent transactions. How it'll work without a Z16, without the Telum processor, is someone will make a transaction and the bank will say, hey, that's a little funny. So they'll run a batch job of the person's previous maybe 20 or 50 transactions to see if this new transaction is in line with their spending habits. And running those batch jobs takes a lot of energy, it takes time, it takes manual effort, and it costs the bank money. But with the dual chip processor, well, one chip is processing the current transaction and the kind of data buses moving around the chip, the other chip can run those previous transactions. And when those buses of data meet in the middle there, they can talk to each other and the chip can determine at that point while the transaction is processing in those milliseconds if the transaction is fraudulent or not. So this is saving companies millions of dollars in compute power and a ton of time from employees. The other kind of huge innovation is all around quantum. So how traditional encryption works, your data is encrypted and even the most powerful computer on the planet won't be able to crack that encryption for decades, hundreds of years. But unfortunately, the future is coming in the next 5 to 10 years. Cyber criminals, bad actors are going to get access to quantum computers. And when they do, what used to take decades, centuries to crack, they'll be able to crack in minutes or even seconds, which is a little scary. I mean, you see that these data leaks happen kind of all the time, never from IBM Z mainframes, but when that data is moving through the public cloud, sometimes it's stolen, and these criminals are just sitting on that data, waiting to get access to quantum computers. But what we've developed, since we're such a future-facing organization, especially in the realm of quantum, is we've developed the quantum cryptographic chip, which is embedded in every new IBM Z16 and all of the new IBM Linux 1 machines, which encrypts all of the data at the quantum level so that even when these bad actors get access to quantum computers, your data is still secure, your data is still encrypted, and it'll take these quantum computers now centuries to crack those codes. So there's nothing to really worry about. I want to take a couple of slides coming up to dive into AI on the mainframe. Before I do, does anyone have any questions about kind of open, on, secure, the mainframe in general? I love that some have just kind of been sprinkling in as we've gone along. But let me know if we have any questions before we move on. Cool. So, I mean, AI, is everywhere. I mean, you can't go more than 2 hours without seeing a new AI headline. But really, the industries in which it's delivering the most value are the industries that are using IBM Z machines the most. So in banking and finance with interest rate forecasting, loan processing, um, anti-fraud detection, within trading with algorithmic trading, within claims education for insurance companies, and then so deep into scientific research, even biosecurity, mining, healthcare. These are all industries that are high transactional industries. So they use a mainframe and they can develop amazing AI solutions because of how much data they're sitting on. So these are some case studies. I'm not going to go through all of them, but some of them are truly, truly accelerating their business, saving so much money, saving so much time because of that on-chip AI accelerator in the Telum chip, as well as kind of just this latest focus on AI. So what I want to focus in on is this loan approval. So one of our large lending client realized that the process to approve consumer loans was taking too long, and their customers were getting frustrated, and their customers kept asking them like, hey, when are you going to approve my loan? I need this money. I need this money. And they're realizing that, oh shoot, if we don't speed up this process, we're going to lose customers. They're going to go to other lenders, or they're just going to have a negative view of us in general. So our consulting team worked with them to create a solution leveraging this full AI stack at the bottom of the screen, as well as, so they use Watson machine learning for ZOS on their Z16, leveraging this little pictogram is for Watson Assistant, which is kind of like a chatbot feature. And the impact was a reduction in latency by over 1,000%, or 1,000 times rather, which decreased lender risk and exposure, as well as speeding up these processes by 1,000 times, granting their customers much faster loan approvals. Another of these use cases to dive into is with a government here in the US that realized that the process to determine fraudulent claims was taking up to 40 hours per case. So every time they wanted to look into if something was fraudulent, it would take one person a full working week to figure it out. But leveraging ZOS and Watson machine learning for ZOS and their new Z16, they're now able to process claims and detect fraud in under 1 minute per case, which is just such a crazy reduction in time, and cost. And when it's like my government over here, I want them to reduce cost as much as possible. So truly amazing things are happening in the realm of AI on Z. Next up, I want to just kind of walk through some data. I want to talk about why I have a job, why my team is so focused on getting skills out there into the world. It's because of the insane demand for IBM Z skills. So currently, as it stands, these are global statistics. 60% of mainframe professionals are over the age of 50. 71% of IT leaders say that their teams are currently understaffed. 93% say that it's moderately or extremely challenging to find mainframe skills. So what those three data points right there mean are that teams are already understaffed, teams are already having trouble finding the right skills, and teams are getting older. Folks are going to start retiring in droves. I mean, this is 60% of folks are over the age of 50, but something around 30 to 40% are over the age of 60, meaning that they're set to retire in the next 5 years. And while that's happening, while these companies can't find skills today, executives are recognizing the mainframe's ability to attract new workloads. 91% are expanding their mainframe footprints as a critical priority, meaning that they want to do more. I mean, we talked about how open source this platform is, and it's increasingly open source, so they can do so much more. They can bring so many more workloads onto the mainframe. They can save costs because they're already using the mainframe. They might as well use it for more, but they can't because they don't have the people. They don't have the skills. So that brings us to kind of our final slide here. I'm going to skip past that one. Our final slide here, which is how you can learn the skills today. This is IBM Z Explore. This is the best-in-class learning platform for all things IBM Z. It's completely free. We never ask for a credit card. We never ask for any money here. But what you do in this platform is you get a hands-on, personalized sandbox environment for learning IBM Z. It's your own environment, so if you mess something up, you're not going to create banking outages around the world. You're just going to have to reset the platform and start the challenge over. As you go through the platform, you'll first be targeting your concepts badge. And this is a very progressive learning path where you do step 1, step 2, step 3. Thank you, Zayad, for posting the link in the chat. And as you go through, you learn just a little bit of a lot of things. So you learn what JCL is, the job control language. You submit your first job. Then you'll learn about Unix system services. You'll learn about Rex. You'll do a little bit of Python on the mainframe. And as you go along, you're just learning these terms. You're learning these skills at a very high level that our clients are looking for, that these banks, these government agencies, these are the skills that they're looking for. After about 6 to 10 hours, depending on how good at computer science you are, depending on your experience, you'll earn that concepts badge. Once you earn that concepts badge, you'll unlock so much more learning on the platform. Then you can kind of pursue your advanced badge, which is over here on the right, which is what it sounds like. It's more advanced. Where the concepts badge is, as I mentioned, very progressive, like do step 1, step 2, step 3. The advanced badge is like, hey, here's seven different options. Pick 4 of them that you like the most and complete those challenges. Those challenges are much deeper. They are a little bit more challenging. They take a bit longer, but they're more advanced. I mean, that's why you earn another advanced badge. So Warren, yeah, these 3 squares right here, these boxes, these are industry recognized badges. They're distributed through Credly. And if you're applying for IBM Z roles, our clients out there know about IBM Z Explore. So if they see that you have your concepts badge or your advanced badge, they'll know that you understand the platform. You have some foundational understanding of IBM Z, which we learned going into this session, most of you didn't even know what IBM Z was. Most of your peers don't know what a mainframe is. So if you can demonstrate that you have some hands-on experience on the platform, it's not gonna guarantee anything. There's no guarantees in getting a job, of course, but it's gonna move your resume up to the top of the stack. I meet with our clients every single week, and when students ask them, what are you looking for in hiring? They say, I'm looking for the Z Explore badge. Because again, it's teaching you those foundational skills, but it's also showing these employers that you're willing to go above and beyond. You're willing to take time out of your day, out of your free time, to learn more. And they want to see you interested in learning more skills, because that means that they'll invest in you in these careers. They'll invest in you because they know that you will keep on pushing. You'll keep learning new skills. You'll bring new business for them, and you'll grow yourself. You'll grow your own career. Pretty new to the platform is our Z Explore All-Star badge. And what this badge is, you'll see different challenges tagged with the All-Star flair in the platform. This is a way to kind of encourage you to keep on learning into our extended section. The extended section on Z Explore is really exciting because we are consistently adding new challenges to the platform in line with what our clients are asking for. Like just a couple months back, our clients have been really hounding us. They're like, hey, we need to train our own people. We need people to better understand MQ, which is a messaging service. They're like, what are you guys doing to promote MQ skills? And we're like, let's add a new challenge onto Z Explore. And so now you can go on Z Explore, you can learn about MQ, you can add that as a skill set on your resume, and you can earn the All-Star badge as you complete those challenges, further highlighting the skills that you've learned. I do want to really highlight the community discussion boards on Z Explore. If you ever get stuck along the way, which you might, you probably will, it's a new technology that you're learning. The community discussion boards are amazing. You just kind of search the problem that you're having. Let's say you're in the Python challenge, you're on stage 3 and you can't figure out what to do. You can't figure out why you keep getting error messages. You just go to the forum, the discussion board, and you search Python step 3. And someone will probably have had the problem that you're seeing. And so you can review what they did. Someone probably came in and replied to the response to help them. But if you can't find anyone talking about the problem that you are having, then you can always just start your own thread. And someone from our team or someone from our community will get back to you to help you as soon as possible. So that's what I have for you all. Does anyone have any questions about IBM Z Explore, IBM Z in general, the mainframe, AI on Z, the demand for Z skills, anything and everything? I am super excited and happy to answer questions.
Lucas, I really want to thank you very much for your time you spent with us today. And there was a lot of good knowledge we learned from you. And I think everybody's excited about this, IBM Z.
Recording stopped.
And I would again, I want to say the same thing. I want to